Okay, welcome students to 7.4, geometrically defined vectors and applications. Okay, vector terminology. A vector quantity involves magnitude and direction. So there's a magnitude or a value, and then there's a direction that that value is going. So both magnitude and direction. A vector is used to represent a vector quantity. The length of a vector A is called the magnitude, denoted by the absolute value of A. Okay, it's the magnitude of A. The resultant of vectors A and B, vectors B, so vector A and then vector B, one right after another, is the vector sum A plus B. So a couple parts of the vector. A is the initial point. B is the terminal point. So we're going from initial point to a terminal point. Okay, initial meaning beginning, terminal meaning end. Okay, the vector can be denoted as AB in bold, AB with a vector symbol above it, or we can just call it vector U with a undercase letter that's bolded. Okay, we can define it by the points, or we can define it by just a letter, a lowercase letter. Okay, we can define the sum of two vectors the following ways. Place the initial point of vector B at the terminal point of vector A. And the sum is going to be from the initial point of A to the terminal point of B. And that would be the sum of A to B. The other way that the head to tail method, head to tail, the head of A to the tail of B. The other method is called the parallelogram method, where we place the initial points of A, B together. And we draw a parallelogram where B is parallel to vector B, and A is parallel to vector A, and where those two meet, from the initial points of A and B, we get the sum as well. So it's the diagonal of the parallelogram that we just created. We could call this A, oops, we could call that A prime, if we want MB prime, not to be confused with Optimus. Okay, so let's use this summation of vectors to find some values here. Okay, two forces of 32 and 38 newtons act on a point in the plane. If the angle between the forces is 76 degrees, find the magnitude of the resultant vector. So we have a point here and we have a 76-degree angle. Okay, and we have a couple of vectors. Okay, one's being acted on by 48 newtons, and one's being acted on by 32 newtons. And so in this case, I'm going to use the parallelogram method. .48 newtons and 32 newtons, 48 and 32, and I want to find the diagonal of this guy. Okay, I want to find the resultant vector here. Okay, so how are we going to do this? Well, what I really want to do is use some of the properties of the parallelogram here. This diagonal does not bisect 76. 76 is not bisected, so I can't just say, oh, the top here is 38 and the bottom is 38. Okay, that's not going to work. But what I do know is that let me get rid of this real quick. I'll put the 76 degrees on the outside. Okay, what I do know is that the angles of a quadrilateral, all four of these angles are going to be of a parallelogram are going to add up to 360. 360 degrees is the sum of the angles of a quadrilateral. Okay, they're going to all add up to 360. But I also know that opposite angles of a parallelogram are equal. So if this is a 76-degree angle over here, I know that this is a 76-degree angle over here. If I know this is, we'll call this angle A, okay, and we'll call this angle C. If I know that angle A is something, then I know angle C is the same thing. So we could even label that angle A because they're the same angle. We could call it whatever you want. Maybe X, if you want to label it as a variable, X degrees. So what do I know? I know that 360 is equal to 2 X angles, which are opposite each other, plus 2 times 76 degrees. Okay. So let's solve for that. That's going to be 360 is equal to 2x plus 2 times 76 is, what is that? 152, I want to say. 76 times 2 is, 152. So 152, subtract 152, and we get 360. Let me clear this off. 360 minus 152 is equal to that, 208. I'm going to end up dividing by 2, and so each angle is 104 degrees. So this was 208 is equal to 2x divided by 2, and x was 104 degrees. Okay, so x is 104 here, 104. 104. Okay, so now what do I have? Well, I want the length of the diagonal. I want the magnitude of the resultant vector. Well, I have two sides. Let me highlight what I have here. I have two, oh my gosh. Give me the highlighter, please. Highlight my life. Okay, highlight two sides and a included angle. So what do we use for two sides and an included angle? Yep, law of cosines. So I'm going to say that C, we'll call this C here. Okay. Okay, we'll say C, little c is equal to a squared plus b squared minus 2ab cosine a. We'll let this be the a, I guess. Okay, in this triangle. Okay, and so I'm sorry, this is cosine C. My bad, not A. Okay, and so C squared is equal to 32 squared plus 48 squared minus 2 times 32 times 48 times the cosine of C. Cosine C is going to be equal to, the C is going to be 104. There we go. And so C squared is equal to, plug this in my calculator, I get 32 squared plus 48 squared minus 2 times 32 times 48 times the cosine of 104. And I'm getting 4071.2. Square root that bad boy. Oops. Second square root, second answer. And it's about 63.8 newtons. Okay. 63.8 newtons. Okay, so c squared was about 4071.2. 4071.2. And this gives me c to be approximately 63.8. 63.8 newtons, okay, of resulting force. So using law of cosines. What's a newton, you say? A newton is a kilogram per meter, kilogram meter per second squared. It's force times acceleration, or weight times the acceleration in SI units. Okay, a ship, example 11 here, a ship leaves a port on a bearing of 25 degrees. Okay. Ship leaves a port on a bearing of 25 degrees. Okay. So that's 25 degrees from north. Make it a little bit. Go away. Go away. Okay, so I'll make it a little more accurate. 25 degrees from north is the bearing that it's going. From north, right? Okay, because bearing is always with respect to north, and it's always going clockwise. And travels 61.4 degrees. Okay, 61.4 kilometers. The ship then turns due east. Okay, which way is east? East is this way. It then turns due east and travels a little bit longer at 84.6 kilometers. Okay. How far is the ship from port? So this is kind of a head to tail type of thing. Okay. Head to tail. So we again want to find out, we'd like to find out what this angle is so we can use law of cosines. Okay, so this is going to be a right angle. Okay, so if this angle here is 25 degrees, then what is its complement here? Well, that's going to be 90 minus 25, because this makes this whole thing makes a right triangle right here. Okay, and so its complement is 90 minus 25. 90 minus 25, what is that, 65? So this is a 65-degree angle there. So now what is its supplement? What is that 65 supplement? Well, what's 180 minus 65? What is that, 115? So now its supplement here is 115 degrees. So we have 61.4, 115 degrees, and 84.6. And so we can, again, use law of cosines to figure out what the length here is from the beginning of the trip to the end of the trip. So you use law of cosines. Let's call this angle C. Okay, and we'll call that side C. So again, C squared is equal to A squared plus B squared minus 2AB cosine C. And we get C squared is equal to 61.4 squared plus 84.6 squared minus 2 times 61.4 times 84.6 times the cosine of C, which is 104 degrees. Or sorry, no, 115 degrees, my bad. 115 degrees. Okay. So I'm going to move over here. C squared is going to be approximately what? So let's plug this into the calculator. 61.4 squared plus 84.6 squared minus 2 times 61.4 times 84.6 times the cosine of 115. Okay, and I get about 15,317.65. So that's 15,317.65. Now, how do I get C? Well, I just take the square root of both sides. So C is approximately whatever the square root of this answer is. Second square root, second answer is about 123.8. And what are the units here? 123.8. The units were kilometers, right? Kilometers, so kilometers. Okay. Okay, and that's 7.4, and I will see you in the last section of chapter 7, which is 7.5.